sigma star will denote all possible sentences. So you can say all possible sentences of length 0, union all possible sentence of length 1, union all possible sentence of length 2, union all possible sentences of length 3, union, and so on. So see, you have the infinite possible words you can form. So now, just like in case of the English language, if you have the English language, so you have A to Z and capital A to Z, other small special symbols. So you can form this sentence like this: A star question mark, like this, come. And this is the particular sequence of symbols. First one is A, second one is also A, next is star, question mark, exclamation sign, and then you have the comma. You have the comma. So this is the valid sentence because English alphabet contains all such symbols. But see that whether this sentence has meaning or not. There is no meaning in English language. We don't have any meaning of such language. But whenever you write the word like this, a sentence like this, aim, then you have some meaning. It has some meaning. Here see, blank is also the symbol in the English language. So if you say that I am going, so it means I, then blank symbol, then blank symbol. So you have the string actually. This is the string. That's why I have told you that if you say string or sentence, it don't make any difference. It doesn't make any difference in this particular code. So actually you see the space, but this is the blank symbol, and blank symbol is available in the English alphabet, we believe. So now there are many sentences in English alphabet, in English language, we don't have meaning, and hence if you talk about the English language, so if you have the English language, for denoting the language we will use the letter capital letter L, and say if you have the English language, then English language will denote what? It will denote the all possible sentences, all possible valid sentences of the English language. So now see that in the alphabet of the English language, which sigma is the alphabet of the English language, which contains all symbols, all valid symbols of the English language, small a to small z and capital A to capital Z and other special symbols. And sigma star denotes all possible sentences or all possible strings. So whatever you have the valid sentence of the English language, whatever you have the sentences here, you may have the many possible sentences, and sigma star will denote all possible sentences. Whether it has meaning or not, it is different thing, but this set contains all possible sentences of the English language. That's why we can say English language is the subset of the sigma star, where sigma is what? Sigma is the alphabet of English. So sigma is the alphabet of English language, and hence all valid sentences of English language is the English language, means English language contains the set of all valid sentences, and all these valid sentences are taken from the sigma star. That's why you can say English language is the subset of the sigma star, where sigma is the alphabet of English language. Now actually at this stage you have the capability to define the language. So how you can define any language? You have the sigma. See, one thing is more, you can use sigma for denoting the alphabet, and throughout this course we will use the sigma for the alphabet. If I don't explicitly mention, then sigma you mean that I am going to use the alphabet. But it is not hard and fast rules. You can use A for denoting the alphabet. It is up to, but you have to mention explicitly. You should mention explicitly that I am using the A as the alphabet symbols. Okay. So how we can define this language formally? So a language over the alphabet sigma is a subset of the set sigma star, because you know that sigma star contains all possible sentences, and any language will have the sentences which is taken from the sigma star. That's why language means what? Language means set of sentences, and this set is the subset of sigma star. That's why you can define like this: a language over the alphabet sigma is a subset of the set sigma star. We can take some alphabet, simple alphabet you can take, like I have some language, and in that language I have the symbols 0 and 1. There are two symbols, 0 and 1, and we need to construct the sentences of this language only using the two symbols 0 and 1. So you may have question that how many language you can form with the help of only two symbols. See, you know, even it has the two symbols, but you have infinite many possible strings over the sigma using the only two symbols 0 and 1. So language, we will denote the language by writing the symbols capital L. Let we define language 1. So in the language 1, I can say what, okay, I have the symbols like 0 and 1. I have two symbols, or I can also say that null is also there, no problem. So this is the language. Once I say language, then you should not mean that even the this had I have written 0 and I have written 1. It looks like the symbol, but this is not the symbol. Now this become the sentence, or you can say word or string. So 0 is not a symbol. Now this is the string. What is the string of length 1? And this is also the string of length 1. So here this is the string of length 1, and this is the string of length 1, and this is the string of length 0. Okay. So this is one language. Other language you can say like this, L2. You can say this is the set of string x, and x is taken from, x belongs to sigma star, where sigma star is what? Sigma is what? This 0 and 1. Means x is taken from this set. The string or sentence you can say, this is taken from the sigma star, and you have to put the condition that you can say length of x is equal to 3. So this is also one language. In this language, how many sentences you have? You have only 8 sentences, because length of every word is 3, and you have only the two symbols, so you can form 8 sentences. Now somebody says that, okay, I have other language like L3, and in L3 I have the set of string x which is taken from the sigma star, such that x is equal to xr. So x is equal to xr, and what is xr? xr means reverse of x. So here you have the xr. xr, this means reverse of x. What do you mean by the reverse of x? Say if x is equal to 0, 0, 1, then you will have the xr which is equal to 1, 0, 0. Means if you are reading from left to right, in the reverse of x means you are reading from right to left, like this. So if x is equal to xr, so x and reverse of x is same, then what is this condition? If you read from left to right, and if you read from right to left, if both are same, then this condition is what? This is the palindrome actually. So what are the sentences in this language you will have? You will have the sentences. See, this is also a language of polynomial because reading left to right or right to left is remains same. This is also the satisfy this condition, and this is also satisfy this condition. This also satisfy this condition. This also satisfy this condition. 0, 1, 1, 0. This also satisfy the condition. Reading from left to right or right to left. Okay. So 0, 0, 0, 1, 0, 0, 0. This is also a valid sentence. So this kind of sentences are there in this programming, in this language. So this you can say this is the L3. So you can have L4 also. So every sentence of this language ends with 1, 0. Whatever is at the beginning may be null, maybe nothing also, but every sentence must end with 1, 0. So if your sentence is ending with 1, 0, then these sentences are here. And all such sentences are in the set sigma star. So and so on, you can have the language 5. You can denote any possible language. Using only the simple alphabet, you can have any possible languages. So in some language is very simple, some language has finite number of words or sentences, some language has infinite number of sentences. Like this has infinite number of sentences because length of x can be anything. So you can have of any length. And this is also ends with 1, 0. You can have in many infinite possible sentences in the L4. So some language contains finite number of sentences, some contains infinite number of sentences. So how you can write the language which contains the infinite number of sentences? So this is the notation. You can write the language in the form of the, and this is the form you can write. And actually in this language you have the infinite possible sentences. You cannot list. Or you can use some sentences satisfying this property, and then you can put dot like this. So you will say that okay, in this way you are going to continue, means you have the infinite. So this is one way to denote the infinite language. And see here, this is the finite language because the number of sentences in L1 is finite. If you have the language, then you can also concatenate the language. If you have the L1 is one language, and if you have the L2 is other language, then you can make the concatenation to form the some different language. So say if L1 has only the verb, if sigma contains 0 and 1, these are the only two symbols in alphabet, and if L1 contains 0, 1 and L2 contains 0, 0, 1, 1, for example, then once you concate the language, then you are going to find how many words you will find. First is 0, so you can have 0, sorry, first you can have 0, then you have to take, this is one substring in the sentence. So this is 1, this is 0, this is one string, then you can take this string or this string. If you are taking this string, then you have this bigger string, or 0 you can take 1, 1. Now similarly you can have here, you can have 1, then you have double 0, and here you have the 1, then again you have the options to select. So by concatenating the two language, you have formed this language. So this is the meaning of the concatenation. Similarly, you can make the union. If you can make the L1 union L2, if you make the union, then you will have, similarly, it means, so concatenation means what? Once you say L1 and L2, so L1 concatenation with L2, it means you have the all possible string xy such that x belongs to L1 and y belongs to L2. Now if you go reverse, L2 and L1. So see L1, L2 and L1 and L1, L2, L1, L2 both are not same. Because now in this case, if you have L2, L1, then X will be taken from the L2 and Y will be taken from the L1. So ordering in case of the concatenation is important. However, you can make the union. In case of the union, ordering is not important. So you can have L1 union L2. Once you say L1 union L2, and then it means this will contains the all possible sentences from the L1 as well as from the L2. So you will have 0, 1, and then you will have 0, 0, and 1, 1. So this is the case. If you have the language L1, you can make the Kleene star of this L1. So when you make the Kleene star of this language, it means what? Star means repetition actually. So how many times you can repeat? If you star denotes starting from the 0. So if L1 0, and you know that L1 0 is the null string. So you will have the, and you are making the union, means L1 Kleene star means you have the situation L1 0 union L1 2 union L1 3 union and so on. It means this contains the L0 L1 0 means 0 denotes the 0 times concatenation. In L1 2, and also you will have the L1 L1 1 also. So one time concatenation means the same 0 and 1. If you say L12 L12 means L12, this means since L1 is here, we have taken 0 1. It means 2 times concatenation you are doing 0 and 1. And once you are going to concate like this, then automatically you know that the string will be of length, every string will be of length 2, because first you have to take from here and next you have to take any symbols from here. If you take this, then you can take any one symbol from here. So first part of string contains this symbol from string from the this set, and other part contains the strings from this set. L3 means 3 time concatenation. So this is the, here you will form the bigger strings. So L1 to L1 3, this means concatenation that much number of times. So you have to remember. Okay. So if I say L5, and if sigma is some alphabet, so L5 denote the all possible sentences of length 5. It means what? Sigma is, say for example, you have, this is the 0 and 1. So if you want to form the sentences of length 5, then how many times you need to access this? 5 times. So 5 times once you access, you have the choice. Every time you have the choices. Either you can take 0 or 1. So say first time you can take 0. Again, for the next symbol, you have the choice from 0 or 1. You may take 1. Next, you may further take 1. Next, you may further take 1. Then fourth choice, you may take further 1. So, fifth choice. So this is the way. So 5 means you have to, this is the set, and 5 times you have to access this set. So first time you have list first element from any one element from this set. Second time also you have to list any one element from this set. Maybe you may repeat also. Third time or fourth time you can have any one element. Fifth time also you can have any one. Means 5 times you have to access. So forming the sentences automatically, since this is the alphabet and this is the individual, every time you are going to form, you are increasing by the length 1. So if you have the 5, that's why you are going to form the words of length 5. But since the language, in case of the language can be anything. Like here you have the 2. Every word has length 2. So once every word has length 2 and you are going to make the concatenation like 2 times. So every word has length 2 and you are going to concate. It means you are going to form the word of length 4. Every word will be of length 4 because in this language the sentence is having the word length 2. So this is the exact notion of concatenation. Means once you have the 5 or 6 or 2, it means that much number of times you can access the set or representing the position elements in that positions. Up to have here we have described the concept of the language.